I didn't realize I was the first talk. So maybe before I start jumping into talking about design principles of a sequencing marketplace, um, I would like to start out just by saying that so MEV I don't view MEV as all bad, right? There's MEV is just is value that can be extracted, right? The whole space is about creating value. So there's many positive forms of value, and I think that we need to be very clear about the types of value extraction that we're trying to avoid and those that we're trying to foster. Um, and one way that I like to think about it is just in terms of look at it as we're trying to maximize sort of social welfare of the whole space, and that includes users. So if you have things that increase utility for users, then this is good, right? And when we talk about sandwich attacking as maybe not so good, because it's worse for users or DeFi applications, whereas taking advantage of arbitrage or profit-seeking actions that result in enabling users across different chains to satisfy sort of complex actions across different chains is I view as very positive forms of MEV. And so one of the things that I've been very interested in is the extremely important role that builders will play in this multi-chain universe, right? As we're moving towards having, even just in one ecosystem like Ethereum, many different chains, the only way that we will really enable both scalability, so the horizontal scalability that rollups have achieved, but also users to be able to act sort of seamlessly as if they're in one unified system, is by leveraging the ability of builders to intelligently construct blocks on behalf of users and make credible promises to users about what they will do. And so that's the sort of the backdrop against design principles of a sequencing marketplace. So just to, let's see, is this, the clicker is, oh, okay, there we go. Okay, so in a sequencing marketplace, rollup, I'm specifically focused on rollups, but this could actually apply to chains broadly, right? It doesn't have to apply only to rollups. I'm focusing on the Ethereum ecosystem, so we're looking at multiple chains, or i.e. rollups, that are all part of the Ethereum ecosystem and settled to the L1. But everything that I'm going to talk about today could apply broadly to different L1s as well. So in a sequencing marketplace, rollups are selling their sequencing rights, which generalizes block building rights, because generally PBS auctions are run just in time to build a block between a proposer and builders. Sequencing could be done ahead of time. It could be just in time. I'll get into the differences between them. You're looking at rollups selling some kind of time slot through which the buyer of that time slot can have control over proposing transactions for that rollup during that time frame. And in a sort of unified marketplace, sequencers could be bidding not only for individual sequencing rights of individual rollups, but also for bundles of rollups. And so the winner of in a marketplace, so the winner of some bundle of rollups would temporarily become what we call a shared sequencer for all the rollups it purchased. And through that, it can create a super block. Now, the talk is not about all the many things that a builder can do, or builder/sequencer. There's two sort of equivalent terms for this. But some of them are satisfying complex user intents. Let's say a user wants to make sure that its transactions on one rollup only succeed if its transactions on the other rollup also succeed. This is something that this shared builder/sequencer can promise to satisfy. It can offer various kinds of pre-confirmations ahead of time, so promises about the future. Let's say that it's going to, it learns ahead of time that it's going to be the sequencer in the next hour, then it can promise to include certain transactions, and that can be useful for users. And this is the third point, I think, is the thing that I'm most excited about, which is that it can coordinate synchronous message passing between rollups, and this can be done beyond the scope of this talk, but it can be done in a way where you actually don't put any trust in the builder for integrity of these synchronous interactions. But the builder plays an essential role in ensuring and facilitating that it happens. And so you can simulate flash loans, you can simulate any kind of synchronous interactions that happen between smart contracts in the same VM across different rollups, and these shared builders or sequencers play a fundamental, essential role in coordinating this to happen. So if you're interested in that, I'm going to give a talk at the main ECC event about it. So catch me there, or catch me after, and I can tell you more about this. So key design goals of a sequencing marketplace are, number one, what I call efficiency. So this has something to do with the social welfare of the system and maximizing utility of end users. We want to enable shared sequencing through the joint sale of roll-up time slots, and specifically, if there are parties who value let's say they don't value very highly the ability to be the sequencer for individual rollups, but they value very highly the ability to be a sequencer for multiple rollups at the same time, because that allows them to do really fancy things that allow them to profit more. We want them to be able to take advantage of that, right? And if there are buyers out there who are willing to bid very, very high on a pair of rollups, then we should make sure that we efficiently allocate goods to those who value it the most. But the other thing is rational for sellers. So in designing this sort of unified sequencing marketplace, we want to make sure that it's rational for rollups, and that they'll be making just as much as they would running their own isolated PBS auctions. So a starting point would just be synchronizing the auction in a way that every rollup is effectively running its own auction, but they're just synchronized. And this synchronization means you basically run the auction through some kind of common consensus protocol. You synchronize the time slots across the different rollups so that it just reduces uncertainty. You're not enabling yet a bidder to bid on bundles. They have to bid individually on each item, so on each rollup. But this synchronicity already goes a long way in order to reduce uncertainty for buyers. And if they do win two different rollups, then they will be able to sequence them during exactly the same time slot. An important thing here is for sellers to be able to set reserve prices, which is basically a minimum price, such that the sequencing time slot will only be sold if that price is met. Okay, and you can think of it as sort of acting as a bid on yourself. And so if the reserve price isn't exceeded, then a rollup would have some kind of default operator, as it does today, that just sequences for itself. Reserve prices become extra important when we move to combinatorial auctions for reasons that I'll mention shortly. So in a combinatorial auction, that's where we allow bidders to now bid not only on individual items, okay, but also for bundles of items. So roughly, proposers can bid on any combination or bundle of roll-up blocks. Each bid is for the right to propose that bundle of blocks in a specific time slot. And then the way that we select winners is we look at over all partitions of rollups. This can be very expensive, so this is another topic of how do you do that efficiently, beyond the scope of this talk, but there are tricks. So you select a partition of rollups into bundles that maximizes the auction revenue. And so every rollup will receive at least as high its bid in such an allocation. And so here it's also going to be important for rollups to set some reserve price. If a rollup sets a reserve, which is equivalent to just bidding on itself, right? If the reserve price is too high, then it risks being excluded from bundles. But if it's obviously the incentive compatible thing to do is to set the reserve price to be at least whatever you think the value of your item is, because otherwise it may be sold for less than you would be making if you were to run your own auction. The difficulty of trying to learn what these reserve prices are is sort of the crux of the issue, that and it is very much dependent on whether you're running these auctions ahead of time or just in time, which I'll talk about in a moment. I just want to walk through an example, right? So let's say bidder one submits, 3 on roll-up A, 4 on roll-up B, and 10 on roll-up, the pair of roll-ups A, B. And then we have a second bidder who bids 11 on roll-ups A, B, C, and 3 on roll-up C. Then the most efficient allocation would be to allocate the pair A, B to the first bidder, okay? And then the roll-up C would go to the second bidder, right? So the total, the sum total of bids in this case would be 13. And then there would be a question of how do you split 13, the auction revenue, among the roll-ups A, B, and C. And so there's many different ways that you could do that, right? So you would first of all, you would want to ensure that every roll-up is getting at least its highest bid, right? So the highest individual bid on roll-up A is 3, the highest individual bid on roll-up B is 4, and the highest bid on roll-up C is 3, okay? So you would give at least 3 to roll-up C, at least 3 to roll-up A, at least 4 to roll-up B, but then there's a large surplus remaining, and there's a question of how do you exactly divide that. So I want to talk about ahead of time auctions versus just in time, because this is I think this is an open question to a degree for us too at Espresso, but there's many advantages that can come from running this auction ahead of time, and there are advantages that can come from running them just in time, and there are trade-offs of each. So one of the main reasons of one of the main advantages of running ahead of time auctions is that it's much easier to run the auction in a censorship-resistant way if you're running it over a long period of time. What do I mean by censorship-resistant? In normal PBS, the proposer is running an auction on its own, and the rest of the world doesn't need to know whether the auction result is correct or not. Like, only the proposer needs to know that it's running the auction correctly. But if we're running a joint combined auction among many sellers, in this case roll-ups, and the auction is designed in order to ensure that everyone is getting their fair share of the revenue, then it is very important for the world to know that the auction was run correctly. And one way of characterizing that is that you want to make sure that whoever is operating the auction isn't censoring some bids or taking side payments. I mean, this is very much the same thing as when Ethereum talks about capturing MEV in the protocol itself with MEV burn or execution tickets. It's exactly the same concern. It's much easier to do censorship resistant bidding if you're running an auction in advance, because you have a longer time to, say, collect bids through a consensus and agree on the auction results. And so it's very difficult to do so through some kind of distributed transparent consensus protocol. The downside of ahead of time auctions are that bids, well, actually, this can act as both a downside and an upside. So bids are an expected value, okay? So for builders out there, this may seem like, oh, how do we even deal with this, right? I mean, you can look at your expected value over time, but MEV is extremely spiky, right? So there's also some time discounting you'd probably want to take into account in terms of present value versus future value. So I think one in particular, when we talk about combinatorial auctions where you might be bidding on pairs of rollups, it might be very difficult ahead of time to predict which pair of rollups is valued more, right? Because the opportunity to, maybe there's two rollups that are communicating very often, and then it's obvious, but sometimes some cross chain opportunity may arise, and that's very unpredictable. So it's hard to predict which bundles are valuable. On the other hand, the upshot of this is it's very easy. Remember, the goals is rationality of the sellers, roll-ups. It's very easy for roll-ups to set reserve prices in this ahead of time case, because they don't need to be sophisticated in terms of detecting these once in a blue moon MEV opportunities. They can just sort of estimate over time, or even play around with adjusting the reserve price to figure out what the expected value is. Because expected values don't change very often, another downside of running things ahead of time is that it can lead to single winners. And that may be a reason to run lotteries instead of auctions. which is another option. There's also multi-block MEV concerns. I don't view multi-block MEV as per se bad. I mean, if there's value to be extracted from controlling multiple blocks, that could be a good thing. But when people talk about multi-block MEV, the main concern that they're concerned about is that if somebody knows that they're also going to be the builder or sequencer in tomorrow, and they're the builder / sequencer today, they could just freeze all transactions and in order to increase the arbitrage that they can extract tomorrow. And that's bad for users, and it's bad for LPs of DeFi protocols. So whereas with PBS today, right, if you are the builder in this moment, you don't know that you're going to be the builder tomorrow. So you have maybe some probability of being it, but you have competition with everyone else. So if you freeze transactions and increase arbitrage, you're going to have to pay more for the opportunity to be the builder tomorrow. Here, you have a freebie on being the sequencer / builder tomorrow because you know already that you're going to be that entity, so you could increase the arbitrage and take it all for yourself. So we have to come up with ways to deal with that if we are going to run things ahead of time. So just-in-time is similar to PBS. Bids are submitted once during block production. Generally they're run by proposers today. They could be run by, this can be part of a secondary market for sequencers to also resell building opportunities. But it would be nice to do this also for combinatorial auctions where builders can bid for simultaneously on the ability to build for multiple rollups at once, because it's just in time that those values are most known to builders. So if we want to use builders to enable more synchronous interactions between rollups, then running a combinatorial synchronized auction just in time may be a really good thing. Can somebody give me a 5-minute warning or something? I don't have a good concept of time. Okay, so I want to talk about running potentially both auctions, okay? So you could use the ahead of time auction first to allocate, rollups to sequencers, and you would be leveraging this ahead of time auction in order to distribute distribute value to rollups. And so here, the nice thing is that you can run it in a censorship-resistant way, transparently on chain. It's easier to set reserve prices, so it's easier to ensure that there's no, gaming of the system, and that rollups are getting their fair share of the expected value. Okay, and if the expected value is actually not too time discounted and is close to the true average of MEV over time, then this would work great, right? I don't know the answer to that question. I think more research has to be done, but this could be a very, very good solution. And then the sequencers can act as the sellers in this second just-in-time combinatorial auction for block building. And the goal of the second auction is we don't need to worry about distributing value to rollups anymore. They've already gotten their fair share of the expected value in the first auction. The second auction is totally focused just on creating efficiency for end users, right? So ensuring that builders can bid on bundles of rollups in order to satisfy complex user intents, right? So the second auction is for efficient allocation of rollup bundles to builders to enable shared sequencing, and it also enables builders to take advantage of cross rollup MEV. It's saying the same thing. It's just from a builder, sort of profit-seeking perspective. From a user perspective, this is also good too. So the multi-slot MEV problem I described earlier, right? The problem is that a malicious builder that controls multiple slots is incentivized to delay transactions, right? And that could increase MEV, which is not necessarily a problem, but it hurts users and DeFi LPs. The reason, this could happen today. I think the main reason it doesn't happen in Ethereum today is simply because the vast majority of stake is in the hands of sort of non-sophisticated actors, and so there isn't a ton of collusion in terms of taking advantage of the fact that some probability distribution over the fact that you're going to be the proposer tomorrow, and you could take advantage of that. So it just doesn't happen to a great degree today. But if we the problem today with electing random proposers is that it's also very inefficient, and the proposers just end up getting all the value from rerunning sort of auctions with builders, and that's not that's not captured in the protocol. And this wouldn't work well in particular for rollups, because if you select random proposers, then there's no real way to make sure that rollups end up capturing their fair share of MEV, and it would do much better just running their own PBS auctions on their own. So it wouldn't be good to elect random proposers in this setting, which is essentially saying, let's allocate the sequencing rights over all rollups to someone random and then let them resell it in a secondary auction. Like, that wouldn't be a very good idea. It wouldn't satisfy one of the main goals we started off with. So this is, as I mentioned, this is mainly an issue for ahead of time auctions. It's not an issue for just in time auctions. So some things that we can do, this is my last slide, to address the multi-slot MEV issue. So one is we can play around with inserting random proposers somewhere, maybe every second block. Personally, I don't think this is a good idea, but I wanted to put it out there just in case somebody runs with it and thinks, oh, actually this could really help. Something that is, I think, quite interesting is, so running this, instead of running this auction as a standard auction, we can run it as a lottery. And even though people are buying the lottery tickets ahead of time, they don't need to learn that they won the lottery ahead of time, right? So they can learn that they won the lottery just in time when they're producing a block. And so the property here is that when you're producing a block today, you don't know, even though you bought the tickets ahead of time, whether you're going to be the lottery winner tomorrow. You only have some probability distribution over the chance that you have to be the builder or sequencer tomorrow, but this is going to exponentially decay over the next K blocks. So you might know, oh, I have a 50% chance of being the builder tomorrow. So if I delay transactions, then I could potentially, increase my own arbitrage. But unless you can double your profits, if you only have a 50% chance of being the proposer tomorrow, you wouldn't do that. So I think an open question, I'd love people to, if people have thought about this, that would be awesome. But how, when analyzing this multi-slot MEV issue, if you make slots really small, let's say they're, I don't know, like 10-second slots, right? By delaying transactions 10 seconds, how much can you actually increase the arbitrage, for that you could possibly capture in the next 10 seconds, right? If it's less than double in general, then if you have sufficient competition and no player is going to have greater than a 50% chance of winning the lottery tomorrow, then it's just, the problem kind of goes away. And it's also bounded, right? So the delaying, you won't have an incentive to delay things for 10 slots, because your probability of controlling 10 consecutive slots is going down exponentially. So 1 over 1,000 if you're a 50% chance of winning the lottery, which is already high. I think it's probably for any individual player will be closer to 10%. You can have multiple proposers so that nobody actually ever has control over block building, and everyone's sort of competing simultaneously, and you resolve all their proposals. And this could remove this multi-slot MEV problem, but it would reduce the benefits of shared sequencing overall, and people could probably still take advantage of arbitrage, but you wouldn't enable synchronous interactions between chains or things like that. So a lot of the benefits of shared sequencing goes away with these multi-proposer designs in a multi-chain context. You can also just have a reputation system. So today, one of the reasons why things work quite well for rollups is that the sequencer is trusted not to play any games. Right? Well, we can generalize that and say, well, we can have an allow list for who can participate in the auction or lottery. And if people are known to be carrying out these attacks, then they just get kicked out. So lots of things to consider. Thanks for inviting me to give a talk. And I'd love to continue the conversation. This was mostly to stimulate discussion.